In this video, I'm going to be covering the procedure for the turbulent and laminar mixing lab. First off, we're going to talk about safety. When considering safety, we want to look at the materials and the equipment that we're using. When you enter the lab, you're going to have 3 beakers set up for you and an overhead stirrer. These 3 beakers are filled with an 80% glycerol mixture with water that's been dyed red, a beaker of 6% bleach, and a beaker of the red dye. None of these materials are particularly hazardous. Glycerol is used in hand lotion products, for example. Red dye is used in food. However, many people have allergies to red dye, so that's something to consider when handling it. The bleach is an irritant, especially if it comes into contact with your eyes or if you ingest it. It can also irritate your skin. From this, there are a few PPE recommendations. We recommend that you use gloves when handling these materials. That'll protect your hands from coming into contact. A lab coat is optional, it's not required. It can be helpful though if you're worried about these materials getting on your clothes. The red dye will stain your clothes very easily, and the bleach will also discolor your clothes. With that, with any lab here, you're going to need long pants, closed-toed shoes, and eye protection. Those are the main safety considerations when looking at the materials. The overhead stirrer is the main equipment hazard. Here we have a rotating shaft that can reach high speeds. And so while rotating, if it catches a piece of clothing or your skin, it can do harm. So pay attention to that. In addition, make sure that will not come in contact with the beaker that it is stirring in, as that could damage the equipment as well. Moving on to the procedure, when you begin your lab, your setup is going to look very similar to this. And what you need to do is first set your stirrer to 750 RPM. You can adjust the stirrer using this knob here. Starting and stopping the stirrer is done by quick pressing the button here, and you can hold down the button to turn it on or off completely, although you will not have to do that necessarily. So I've set it to 750 RPM and we're going to start the mixing. Now, the purpose of this lab is to compare the effects of laminar and turbulent mixing. A key parameter when considering these effects is mixing time. That is the time it takes for a solution to reach a certain degree of being homogeneous or not. So in this case, you can see the behavior of the mixture at 750 RPM. You can see some effects of turbulence here with the motion of the liquid. And as you continue playing around with different speeds, you'll notice that we're generally operating within the transition range. At this speed, you will also see some effects of laminar flow, but we'll get into that later. So the first thing after you set the 750 RPM, I'm going to come closer to show this effect. You're going to add 2 milliliters of bleach. You'll use a pipette to do it. This one is marked with a yellow sticker to show you're using it with bleach. And it is marked with different levels of volume. And so you're going to take up 2 milliliters of bleach and you're going to add it to the solution with a timer going. And you're going to measure the mixing time. An important thing to consider with this is that the mixing time is different from the reaction time. This bleach will neutralize the red dye in the beaker. However, it'll take longer to neutralize the dye than it will to become a homogeneous mixture. So I'm going to add it to the mixture here. And you can see distinct streamlines of the bleach. And now that's about completely mixed there. So that would be the mix time, just a few seconds. We're going to continue and let it mix at 750 RPM and it'll gradually become clearer. Now that the mixture has become clear, and when you're doing the lab, it doesn't need to get this clear either to demonstrate the principles we want you to see for the next part. And in fact, this isn't even completely clear yet. It still has a pink hue. It doesn't show up very well on the camera. So now that I've reached this point, what I'm going to do, I'm going to stop the stirrer and put it down to 200 RPM. You don't necessarily need to stop the stirrer in between this step. However, it helps break the already developed streamlines and flow within the beaker. And so I've set it to 200 RPM on the overhead stirrer. I click it to start again, and it will begin spinning. Now this part is a little finicky, and there's a few things that can happen here. Regardless of what happens, you will still be able to see the principle we want to show. So I'm going to add 2 milliliters of dye with this pipette that's marked with red tape to the solution. And for the best results, it's very particular where you are going to add the dye. I'm going to show in this video a few different possibilities of what it might look like depending where you add the dye at. But you want to be about an inch below the stirrer and about halfway between the wall and the impeller. Now I'm going to add the dye, and you're going to notice a few things happen. At this lower, more laminar flow stage, we see streamlines start to show up here. We can see kind of a toroid where the dye is spinning around right about here. And then we also see a band here where it's still clear from where the bleach was. And inside the band, we also see that swirling. Depending where you add the dye, you could get more dye in this band here or more outside, in which this part will be clearer. But with this laminar flow, we're going to see this kind of separation for hours on end. And it'll stay like this, going through its motions. So as you're measuring the mixing time, that's more of a formality to emphasize this effect, that when you're having this laminar flow, you're not getting a homogeneous mixture here. And this has some very important implications that you'll want to consider. In the actual lab, you'll do this part and then you can skip down to do some post-lab questions. That'll ask you to draw some of these streamlines that you see and emphasize the band and the way that the dye is moving through the liquid. And so here I'm going to show some of the other ways that this might look depending where you add the dye. So in this example, I wanted to emphasize what it might look like if we could be very precise with how we introduce the dye to this beaker. And so as you can see here, the dye is completely contained in that bottom band that I was pointing out earlier. And as I mentioned before, this video had already been going for about half an hour, and that band will stay in there without diffusing through the beaker for several more hours. And so this is kind of just a cool thing, a visual representation of how the laminar flow is going to affect your mixing. So as you've continued to let this mix, and you'll notice that you continue to have a band of clear here where the dye won't penetrate, and up here more of the dye. You'll then switch the stirrer to 750 RPM again, and you'll watch as it mixes. And you can see it takes a little bit, but it's very quick to break those structures that were created from the laminar flow within the mixture. And about there, it's homogeneous. So just a few seconds.